Welcome and hello. This is a support video in HEC ResSim, and in this video I'm going to title it Multiple Demands. I got an email from one of my viewers who asked about if we have two demands, agricultural and urban, how should we define those demands in HEC ResSim? So I don't have too many details, but what I will show you in this video is one way to set up a model with multiple demands downstream of a reservoir. In fact, what you see on the screen here is my model. I happen to be in the simulation module because everything is set up and ready to run. But before I run it and look at results, I'll just give a quick overview of some of the model inputs. So we're starting up here at this node at the very top, and we're flowing downward. I've labeled my junctions, these red dots, CP1, CP2, CP3, 4, 5, and 6. We have a constant inflow at CP1 of 1100 CFS. So I've got that defined right here, 1100 CFS. This is going to be a 12-month simulation. The reservoir spans from CP2 down to the dam face of CP3. We'll take a look at the reservoir rules in just a moment. And then downstream of the dam, we have CP4, this junction which has a diversion, which is serving the agricultural demand. And then downstream of that, we have CP5 underscore urban. I know the text is a little bit small, but that's what it is. And that has a diversion for urban demand. And then finally, one more downstream reach to our final junction, which is what I'm using for the downstream control rule to set a minimum in-stream flow requirement. Let's take a look at our diversions now. Like I mentioned, our inflow to the system is a constant 1100 CFS for all year long. If we go right click and then edit diversion properties, this is the diversion underscore ag. And what you're seeing here are the actual diversion numbers. The first 4 months of the year, we have a diversion requirement of 300 CFS. The next 4 months of the year, we have a 600 CFS diversion. And then the last 3 months of the year, another 300 CFS is the diversion. There's a number of other ways to define the diversion, but I just did it this way with monthly accounting. Okay, so I'll click OK. The urban diversion we can also look at by just clicking on edit. I guess I could have changed that up here, no big deal. But just like agricultural, I'm defining it on a monthly basis. So it starts at 400 CFS, it ramps up to 500 CFS, and then back down. All right, let's take a look at our reservoir now. So I'm going to actually just go right click, edit run, click on reservoirs now. This is the one and only reservoir. It's called Reservoir A. Over here in the physical tab, we have the dam. We have 3 different gates on a controlled outlet. So you can see the physical characteristics of the dam and the pool. If I click on the operations tab, now what we see is this CP6 downstream control rule. So that downstream most junction on the map, which we saw earlier, I'll point it out again, it had a blue square around it, which identified it as a target for a downstream control rule, which I've set to have a minimum of 200 CFS delivered to it year round. Here's the downstream location, CP6, and then the parameter is flow, and it's just a constant 200 CFS. That rule is copied to both of my zones. If I click on one of the zone names, you can see that we have a guide curve set at 1480, and then the top of the flood control zone is right here at 1500. So let's go ahead and run the model and see what the results look like. I'll click OK there. I'll click on compute. That ran. Let's take a look at the flow rate through each of the reaches. So starting with CP1 to CP2, if we click on plot, no surprise there, it's a constant 1100 CFS. Downstream of the reservoir, this is kind of a small reach, but I should be able to right click, look at the plot. It looks like we're releasing exactly 1100 for the first 4 months. And then after that, when the downstream demands increase, specifically for ag demand, then we're releasing more than 1100. It looks like up to 1300 CFS for the months of July and August, and then less than 1100 down here at like 950, 900 CFS for the last 4 months of the simulation. If we subtract the ag flow from that flow rate plot we just saw, we should see the flow between CP4 and CP5. So here it is. It starts at a constant 800 CFS, and that's less than that for the remainder of the calendar year. And then finally, from CP5 down to CP6, if I click on plot, here we go. It starts at 400 CFS. And then after the first 4 months, it looks like that 200 CFS minimum flow constraint of 200 CFS is active. So what that tells me is I think starting in May, we're going to have a shortage in the reservoir volume, meaning it's going to drop below its guide curve elevation of 1480. Let's check out the plot of the reservoir now. Yep, and sure enough, right when the releases increased, starting on May 1st to accommodate the increased demand, specifically the agricultural demand, we started seeing a decrease in the water surface elevation and hence the storage in the reservoir up until September 1st. And that is when the agricultural demand dropped back down from 600 CFS to 300 CFS, and the reservoir was only releasing as much as it needed to satisfy that 200 CFS in-stream flow demand that was specified by the downstream control rule. And it looks like by the end of the year, the water surface has almost recovered back up to its guide curve elevation of 1480. Let's go ahead and zoom in just to see how low this water surface elevation got. So it looks like we're at about 1432 approximately. We could do a lot of things to change that. So say for instance, the in-stream flow demand at our downstream most node, CP6, is not 200 CFS, but only 100 CFS. Let's run that simulation, take a look at the results, and I suspect that our minimum storage or our minimum elevation in the reservoir will not be as low as 1432, probably something a little bit higher. So I'm going to make that edit just here in the simulation itself. I'm going to click on reservoirs, change this from 200 to 100, click apply, and that should have copied over here. Yep, just making sure. Okay, okay. Go simulation and save, and then compute that alternative. Click on close, and then right click, take a look at the plot now. Looks like we have the same general shape right here, but if I zoom in, I don't think the water surface elevation got quite as low as it did before. So now we're looking at 1463, 1464. And if I look at the flow through that last reach from CP5 to CP6, we have a minimum of 100 CFS is enforced, but strangely enough, it looks like it's only from May until sometime in October, I'm guessing, which is probably when the guide curve elevation has been reestablished in the reservoir. So let's just check that out. Right click and plot, and make that a little bit larger. And then let me just zoom in here towards the end of October, right like that. Yeah, so it looks like towards the end of October 16th or 17th, that's when the reservoir continued to release as much as it needed to maintain that 1480 guide curve elevation. All right, well, that's it for this support video. What we did was add multiple diversions representing demands in our system, which were downstream of a reservoir, and that reservoir used a downstream control rule to ensure that another downstream node met its required in-stream flow requirement.